Hello everyone, in previous lesson we introduced the definition of sine and cosine and we extended the definition to the regular angle. The reason I show this picture again just because, as you know, according to the definition we actually have to use the coordinates of the angle to figure out the definition. So that's why I keep telling you this is very, very important fact, and you need to keep in mind how do we use the coordinates to find the sine or cosine. So the first, let's use one example to quickly review the lesson we talked about before. So in this example here, we need to find the sine and cosine of the angle negative 225. Let's draw this angle first. So as we know, when we draw the angle, we always initial ray starting with here. And since this is negative, so we are going to rotate. Yes, you're right. Rotate clockwise. And also, since it's 225, so let's check. This is 90 degree, 180 degrees. So it's going to be more than that. And we probably is not accurate one, but we get an idea. So it's negative 225 degree. So, and remember, how do we find the answer of both? We actually check the terminal ray. So the most important part is where terminal ray intersect the unit circle. This point, let's say x and y, and this point, the coordinates will give us a value here. So let's go back to check which one actually have the same terminal ray as 225. So the reason we mentioned that because 225 actually same as the terminal with 135 degree, and the coordinates we already see that it's negative. This is value. So let's write down here. So this is negative. And also we know that for sine, in unit circle, I just want to readdress again. In unit circle, the definition is y, so it's going to be this. And the cosine, the definition in the unit circle is going to be x coordinate, and we just need to write down. Okay, that's it. That's basically how do we find the value of the sine and cosine for a random angle. Today we're going to discover something more about sine and cosine. So let's just quickly review the definition again. As we mentioned in the random circle, let's say this circle, the radius is r, and if we draw the random angle, for example, let's use a different color. It's initial ray, and I rotate clockwise, no counterclockwise. So this angle is, let's say, beta. And we know the terminal ray intersect the circle with x and y. So the definition for sine, let's say beta, is the y coordinate over r, and also cosine beta is x over r. Okay, so the r is the radius of the circle. So what we are going to do is, by the way, there's one thing I want to remind you. Remember, this circle, the center is 0, 0, so the coordinates x, y always have this relation. So what we do is we are going to put the square around this, and we figure out, hey, what is the answer of that? So let's sine beta square, basically this value gets squared, so it's y over r squared. And this is going to be x over r squared. Let's just simplify this. R squared, y squared, r squared, x squared. They both have same denominator, so we just keep them together and we can add top. If you go back to check here, x squared plus y squared is r squared. So the top one is actually r squared. which is 1. Because the same numbers over divided by the same number is going to be 1. So the fact is, let's go back to the very beginning. The square of each part, the sum of sine square and cosine square equal to 1. And there's another way we write this one. So instead of writing sine beta square, we can put a square here. It's just a different way to write it. Sine square. This is a very, very special way to write in trigonometric function. We can put the exponents just between this one. So it's saying equal to 1. So this is what we discover. So you may wonder, what about in unit circle? It's going to be the same thing. It's going to be the same thing. The only difference, remember, the unit circle. Sorry for the slanted line. The unit circle, this radius is 1. So x squared plus y squared is equal to 1. So let's see, if I draw the random angle here, and the terminal intersect unit circle at xy. So sine, let's see, still we use beta. Sine is going to be y. Cosine beta is going to be x. This is only works in unit circle. So if we just use same thing, we square them. Again, this time I use this symbol, meaning y squared plus x squared equal to what? Equal to 1. So this is equal to 1. So no matter what kind of circle we're talking about, we can always find this pure fact. Sine squared plus cosine squared equal to 1. So this is a very, very important fact about sine and cosine. So we call this one as, let's use a blue one. So the Pythagorean identity. Pythagorean is actually coming from, remember, we can still use a right angle here to figure out the relation. And the beginning, how do we find the equation of circle? We also actually coming from the right triangle. So that's why this pure fact is called Pythagorean identity, meaning sine squared plus cosine squared is always equal to 1. This is very important. No matter what kind of trigonometry lesson you are going to learn, this is a very important fact you're always gonna use. So in next video, we are going to use 2 examples to use this one to do some more practice. Hope this video is helpful. See you soon.